Today I'll go through a little bit of the company background as well as my product, the ChronoPHY. To give a little bit of background on Aeonsemi, we are a startup. However, we are kind of entering into the later stages here. We're founded in 2018, so just about 5 years old now. And we actually have shipped product, lots of product. It's 15 million pieces of our all silicon high performance oscillators. And something we're very proud of is zero quality returns. So it really showcases the robustness of the product. We are now up to 80 plus employees. Our headquarters is in Santa Clara. We also have an office in China. And really, you know, the founders and the technical team, they come from various, you know, companies around the valley that specialize in mixed signal, DSP, and precision timing. That really makes a sense as you look at what product lines we have, which are timing and networking. And you know, both of these product lines are going into the same markets: communications, industrial, and automotive. So these core technologies that I mentioned, they really come together with our two product lines. The ChronoPHY, which I'll speak about, we really feature low power, long reach, time-sensitive networking features, and integrate some advanced timing features as well. And then the Arcadium is our timing product, which is a ultra reliable monolithic oscillator. So I mentioned that our 10G base T PHY, we call it ChronoPHY, and it is a multi-rate PHY. And the reason we call it ChronoPHY is we do have best-in-class latency, determinacy, and some advanced timing features. So the chrono time link makes a lot of sense. So really, I think it's important to first answer why. Why do we choose a 10G base T PHY? And you know, looking around the markets, we really see a migration to 10G over the next few years. Some faster than others, but really kind of some massive market opportunities here. I'll start with the enterprise, of course, talking about, you know, companies as well as campuses and hospitals, and you know, all these networks are being upgraded, and we're starting to see that with the not only the switches that are going into these buildings, but the enterprise access points are upgrading kind of from 6 to 6E to 7, which will require a 10G port. On the service provider side, a lot of the advanced timing features on the chip are for radio units and distribution units as part of a 5G infrastructure build out. That's still going on kind of slowly but surely, and we see a lot of opportunity there. Broadband access, both kind of on the retail side as well as from the service providers themselves, these gateways are consistently being upgraded, you know, from 1G to 2.5G to 5G and 10G, and we see that in all sorts of fiber cable, all sorts of different access devices. And lastly, on industrial, we see a lot of opportunity for industrial video, factory automation, a lot of machine vision going into AI systems, getting that data real time. We have nice features for that with our low latency and some of the advanced timing. Just to kind of briefly highlight some of the features that we have here. So I mentioned ultra low latency, you know, under 1 nanosecond to the wire, as well as under 2 nanoseconds variation. So not only getting the data there quickly, but also on time. And we have excellent reach. So we can go above the 100-meter standard on 5E cable for 2.5 and 5G speeds. Kind of another unique feature is the dual SerDes. So we have both a copper and a fiber interface. On the advanced timing side, we've integrated a sync-E jitter filter, as well as a sync-E output clock. This is in addition to standard 1588 timestamping features. These are more advanced features on there. We are low power, 2.7 watt at 10G, and working to improve that via firmware and future revisions. And then, on the hardware implementation side, we try to be as easy as possible to implement. So only 2 voltage rails and a flexible clock input. To highlight some of the advanced features, I just want to do a quick block diagram of a 5G base station. And on the left, you can see the current way things are done, which is there's 2 PHYs, an analog switch, and an external sync EPLL. The reason for this is you have kind of 2 options for the data input, either the electrical or the optical, and the network baseband SoC only really wants one of those. And then on the timing side, you're getting the 25 megahertz reference clock from the outside world, and that's being entered into a sync EPLL, which is then generating the PTP clock as well as the reference clocks for the radio on chip and the PHY. So what we've done is we've consolidated the second PHY, the analog switch, and the sync EPLL. So we've got both the copper and the optical interface, just one interface to the network baseband SoC, and then we can do the sync EPLL functions internal to our chip. So we can generate the 156.25 megahertz as well as the 122.88 megahertz sync E clocks for the other processors on the board. And then just to reiterate kind of how simple it is to implement our solution hardware-wise. So the first is the voltage rail. So it's really just 0.7 and 1.8 for power inputs. And then on the clock side, we are fairly flexible. Lowest cost option, of course, being the crystal, but if you have a 50 megahertz CMOS clock or an LVDS or LVPECL at 156.25 on your board, we can take those in as a reference clock as well. And then as far as the firmware load, of course, you have a host processor. We can take it from there, but we also have a SPI port if you won't need an external flash. And just to highlight the IEEE spec for reach is really 100 meters, especially at the NG speeds, as we call it. So 2.5 and 5G, they're supposed to be able to get to 100 meters on Cat5e, which is, I can't believe this, but quickly becoming a legacy cable at this point. And we're able to exceed the 100 meter spec, going all the way to 160 meters. And this becomes important in lots of different applications, especially with how common Cat5e is in a lot of spaces. We had an application where there was a museum that had long reach for interactive displays, and Cat5 was already installed there. However, they needed to run 5G, so this was a nice solution for them. I've also gotten inquiries from cable access customers who are saying, hey, our customers have 5E already installed in their homes. How far can they go? We can run the 5G up to 160 meters. Then we're also pushing to improve our performance on 10G on Cat5e as well, which is you're supposed to use 6 or 6A for 10G, but we're trying to get as close to 100 as possible on that as well. So the ChronoPHY, it really is a family. We break down the family by speed grade. So the first 2 rows are the 10G parts, and then there's the 5G max and the 2.5G max part. Across all of the speed grades, the 7x7 BGA81 is the common pin-to-pin compatible package. And then the J versions that you see there, those integrate the Sync E jitter filter as well as the Sync E output clock functionality. And then the 11x11 package integrates the dual media capability. And this is my last slide. We do have the all the documentation and the eval boards, as well as the GUI and firmware to really get you started. So kind of the first pass at any part, right, is the data sheet. As you get into the design itself, we do have a hardware design guide, and then looking at the components around the PHY, we are building out a recommended RJ45 transformer and integrated magjack guide. This takes quite a bit of testing, but we want to make sure we have a kind of a menu of parts to choose from that we've tested against. And then for the eval board itself, we have the documentation for that as well.
I'm here to share with you about our precision timing product line. Similar to the 5 product lines, we also cover communication, industrial, and consumer markets, as well as we will be having products in the automotive space coming in November. So here's the lineup of what we currently offer today and what we have on our roadmap. We have a family of all-silicon oscillators and a family of crystal-based oscillators. The all-silicon family of oscillators, we've shipped nearly, I think, exceeding 15 million units, and as Mike mentioned, we had 0 return. So this is a very high-quality product. This monolithic solution has an LC resonator and an ASIC on a single piece of CMOS silicon. We all know that LC resonators are known for not being precise. So our team has developed a proprietary compensation scheme to make it stable over -40 to +105 C. So now let me kind of give you an overview of the evolution of the oscillator technology. Originally, there was the crystal oscillator, and then came the MEMS oscillator. And now Aeonsemi is the first to offer the all-silicon oscillator. The difference mainly here is the first two are co-packaged together with its resonator and then a circuit that helps drive the resonator. In our case, our resonator and our ASIC is in a single CMOS solution, utilizing well-proven CMOS manufacturing and packaging technology. This offers a solution that is very stable in all sorts of environmental stressors. So let me kind of give you the highlights of our silicon oscillator technology. The first family we introduced was called the Arcadium silicon oscillator. You can find the information, specific data sheets on our website. So it is, like I said before, free of quartz and MEMS. So there's no moving parts here. It's programmable, fully programmable. We can offer fixed frequencies to our users from the factory, or our user could even utilize our I2C programmable option. We offer it in industry standard packages. So, you know, these can drop into any of the MEMS or crystal based oscillators in the same package and form factor. We will also have an automotive grade coming in November, and that will open the automotive market for us because we feel that a product like this will be great when there's lots of vibration in EMI environments. Here's the lineup of our all-silicon oscillator portfolio. The first two, the 5000X and the 51X, are release products that we have. And as you can see, we have fixed frequency options. We have pin control options. The pin control options can go up to 3 or 9 different frequencies from one single package. And we also have a digitally controlled version through an I2C, 5003, where the user can change the frequency on the fly or even the output configuration, whether it's LVDS or LVPECL. Then the next family that we have, as I alluded to earlier, will be in November, and that's our 501X family. Similar kind of offering, and this will also have automotive grade. This concludes my summary of our timing products. Thank you very much,